List those real quickly. Russell, can you tell me one?
Composition.
Composition's one of them. Allison, can you tell me another? Decomposition's number 2. Number 3, Alex, what would you say?
Single displacement.
Single displacement. And the 4th, Aaron? Double displacement. Now there are different terms. Your book, single displacement to your book was just simply displacement without single out front. But I will add that. For your review, you need to add it, or for the test, I would add it. And then there's that fancy word, metathesis, for double displacement, that I'm not going to be using that term either. I don't think I've ever heard a real live chemist ever say that word. Okay, so we had covered the first 3 in lecture, and we covered the 4th one in your lab 10. Okay, if you saw this, and it's already balanced for you, if you saw that, Hina, what type is it?
It's a decomposition.
Decomposition. Defend your answer.
There's one reactant and it separates into 2 products.
Okay. You start out with one type of reactant. Don't let it throw you. Sometimes when I would just say one reactant, the fact that there was 2 here threw people a little bit. No. One type of reactant, and it comes apart. Sometimes it goes all the way to elements, and sometimes it just goes to simpler compounds. So, decomposition. Okay, this number 2 right here. Emily, what is it?
It's a double displacement.
Double displacement. And when you look at this, you have these 2 compounds come together, and notice what they have done. They've switched partners, and there's never any doubt about who's going to go off with whom, because opposites attract. So the positive here, and in this country, we write positive first and negative second almost exclusively. There's a couple of exceptions, but we don't need to worry about the exceptions. So the positive here, the copper, is going to kick out the sodium. So it bonds up with the sulfide, and then this nitrate, a polyatomic ion, goes together with that. Okay, this is a new part that you have not heard from me. No, we talked about in single displacement, there had to be a driving force. And at least 2 of you have already asked me about this morning. It's on page 232. And this is not something you memorize. And it's this part that's in kind of that mustard color that's always provided to you. Except if you look at that, all of those are metals with this exception. So if you have a single displacement, you have to make a decision first, will it go? Okay, then if you decide it will go, then you should be able to predict products, and we'll do that in a second. Yeah, Brittany?
The bottom part of the orange box, like where the hydrogen and like
Yeah.
CHG, will that
Go
all,
ahead.
that will all be on
Yeah,
there?
that's all part of
The
it.
entire
That's all
ball,
part of
just
it,
the
yeah.
orange.
They give
So
you
for, like,
way,
gold
this,
and, like,
yeah, this is so typical of our authors. They give you way too much information. Ignore those boxes. So when I say the mustard colored box here, actually
all the way down.
all the way down.
Okay, perfect.
All the way down. And if you Google that, which I did over the weekend, because I didn't have my book at home, I just asked for the activity series, and they don't put all this extra trash in there. You just get that list right down there. So everything there is a metal, except hydrogen, and then if you want to be a Strickler here, that you got a metalloid.
And then would we be given the iodized form for the decomposition? Like what would CO be positive or negative for like the test for when it comes
okay,
to
for a decomposition, let me backtrack, because I think I know what you're getting at. If it's a combination or a decomposition, you do not have to answer the questions about will it go, nor for those 2 do you have to predict the products. So if you have a decomp, I will write it all and assume it goes. And if we have a combination later, likewise. Assume it goes, and I will give you products. For a single displacement, you will be able to predict products, as you did in Lab 11. also now, with a double displacement, as we look at those a little more, we should be able to predict products. Now, did that answer your question? That was the long-winded answer for it.
Yes, but like to know like if it's going to be 2 positive or 3 positive or just.
Oh, okay, I think that question's going to be answered. We know a lot of them already by position,
but
but like copper.
That's what I meant, like
Yeah.
the ones in the D.
Yeah, exactly, exactly. We'll look at that in the first part of the chapter. There's going to be a handful that you'll be responsible for. The rest of them I would let you know. Okay? All right, back to this one, double displacement. You also are going to have the issue of will it go and predict the products. However, we got to take it in slightly different order. If it's a single displacement, you decide it has the potential for being a single displacement, then you use the activity series only for single displacement. You will decide if it's going to go. If it doesn't go, you don't have to write an equation. All right, but double displacement, here's the new part, is if you have a double displacement, go ahead, make them switch partners, and later this morning or Thursday, we'll decide how to write these formulas. That, and this is what Brittany was getting at, the charge on the copper is +2. The charge on this unit is -1, and that's coming later today. So when they go together, you got to decide, well, copper's +2. In fact, let's just do that. When they switch partners, okay, we know who's going to go dancing off with whom, because positives go with negatives. That part I provided you right now. But we know sulfur by position. If you spot sulfur up there, when it takes on a charge, Andrew, what charge does it take on?
-2.
-2. Okay, so if I said, write the formula for me, if you use that trick, the double cross down, that really kind of fails you, because then you have to clean it up. Because the trick would give you 2 to 2, but you clean it up, and you end up here 1 to 1. And then you have a neutral compound. Okay, this part of it.
Is that what they're trying to do, is neutralize each other?
Yeah.
I mean, are they aiming for like charges too?
Yeah. When you have a compound, it's going to be electrically neutral.
So the 2 for 2 would get together faster than the 2 for 3, I guess is what I'm, or, you know what I mean?
It had to, not faster isn't quite the right word.
But they're more likely to pair up if they're the same charge.
Opposite. No.
No, opposite, I know negative and
No.
positive.
If I
get
were a
that.
+1 and you were a -3, oh, I would adore you. Okay?
There's only one.
Because more positive charge, more attraction. But they're going to,
I'm thinking trying to figure out who goes with who.
All you have to know is that there's only 2 off. Like there's a negative guy. He can either go with the positive or the negative. That's it. So negative's automatically going to go with positive. At that
Well
point,
said.
At that point, it doesn't matter if it's 2 positive or 8 positive. As long as it's
Exactly.
positive.
Okay, positive here, negative here. Positive here, negative here. Got 2 on the dance floor. We got a very conservative dance. When they switch partners, we only allow positives to go with negatives. Okay, so this positive goes with that negative. This negative goes with that positive. Then it's an issue. A second issue, how many? Okay, 1 to 1 here. We decided based on charge. Okay, I have a sodium. When I try to do this one, what's the charge on a sodium? Anybody? What's the charge on a sodium? +1. We know it by position. Now, the nitrate, which you haven't been exposed to yet, but you will in the first of chapter 6. Nitrate as a unit, this is called a polyatomic ion. Ion, of course, charged particle. Analyze the words polyatomic. Poly means a few, so a few atoms in this ion, and it acts as a unit. So, when these go together, you do your double cross down, and it works just fine, and that's your formula. You got to get your formulas right first, then you can always play with coefficients. That charges are set in stone, which means formulas are set in stone, and then you balance it by putting in the coefficients necessary. Okay, that was one part. So for a double displacement, as you decided number 2 was, first you got to switch partners, and you've got to come up with what you think the formulas are going to be and balance it. Then after that, the new question is, will it go? Okay, for a double displacement to go, you got to have a driving force, and I have not mentioned this before. A driving force would be if you produce something that is insoluble in water. Okay, this is soluble, and let me see.